Hello, welcome to today's biomechanics screencast. Focuses on centre of mass. As you can see on the specification here, we have to be able to define centre of mass. We've got to know factors affecting the changing position of centre of mass, and also we need to have an understanding of the relationship between centre of mass and how stable different sporting techniques are. Okay, so to start off with, let's have a look at our key definition then. As you can see here, I'll put a picture of a human body. Okay, the black dot here is to symbolise the centre of mass, and by definition, the centre of mass refers to an imaginary point at which a body is balanced in all directions. Now, I've used the human body, okay, here. Now, with the human body, the centre of mass doesn't always stay the same. So sometimes there can be a change in the position of centre of mass. Okay, so what can cause the change in a position of the centre of mass in the human body? The first way it can happen is by raising your arms. So if you raise your arms, what happens there is it brings up the centre of mass and makes it slightly higher. So if the centre of mass rises when arms are raised, okay, so that's our first change in the position of centre of mass in the human body. The second way centre of mass, or the position of the centre of mass, can change within the human body is when we rotate forwards or backwards. And what happens when we rotate forward and backwards is the centre of mass comes outside of the body. Okay, so it doesn't actually remain inside the body, okay, because if the body is to be balanced in all directions, in order for that to happen, it has to come slightly outside of the human body. So center of mass can also change by coming outside the body, usually when the body is rotating forwards or backwards. Okay, so I just want to put those in just so we know what the definition is, but just two slight changes that can take place. And then later in the screencast, we're going to have a look at sporting techniques where moving the centre of mass outside the body is absolutely vital to be successful. But before we do that, let's have a look at our second section then. So we have to know the relationship between centre of mass and stability. Okay, so on here, what I'm going to have a look at now, we're going to look specifically at factors that affect how stable we are. So I'll put here, we're going to use this as our kind of, I suppose, our concrete example, the thing we're going to reference all the way through. So I'll put a bridge position in gymnastics here, so backward rotation there. As you can see in this case, the centre of mass is outside of the body. Okay, so what we need to do then, that's not really important, just so you can see that black dot is to symbolise the centre of mass. What we have to understand then, if we are trying to do certain sporting actions, what factors affect how stable we are? So you might start to pick some things up there. So if you were talking about a bridge in gymnastics, that would be considered stable. And the factors that affect how stable that are come in this way. So we've got the height of the centre of mass is one. So if these are factors, the second one is the line of gravity, size of the baseball, and also the mass of the object, so how much the object weighs. Okay, so if I went down from here, we're going to look at the top 3 bullet points and apply them to different sport examples. So I'm sure you can realise these are the factors that affect stability. We've got to apply them to say, okay, height of centre of mass. That doesn't mean anything at the moment. We've got to apply it to say what makes a position more stable. Okay, so we've got to apply it. Same with line of gravity, same with the size of the base of support. Okay, these are factors, but they have no application at the moment with regard to increasing stability. Right. Let's have a look then. First one we're going to have a look at that is the height of the centre of mass. So I'm sure you can kind of guess this, but if you have a look, I mean, I put it onto this one here for the bridge. So this is stable because the centre of mass is lower. Okay, so the lower the centre of mass, the more stable a performer is. So I'll put into here another example you might link this to. Okay, so for example, a rugby player, when they're preparing to make a tackle, they will lower their centre of mass to get ready to make themselves more stable so they don't get knocked back. You don't see rugby players just before a tackle standing on their tiptoes waiting to tackle someone because they know that their centre of mass is too high, they're going to get pushed straight back. Okay, so they'll lower their centre of mass to increase their stability and make them more difficult to move out the way. Okay, so we'll always use the bridge as an example, but I'll try to give other ones where possible on here and also in lesson. On top of that then, the next factor affecting stability, if we know that the height of centre of mass is 1, okay, let's have a look at the line of gravity. Now the line of gravity, as you can see here, I've put a little red arrow going here. The line of gravity in this case is coming from the centre of mass, okay, and it's coming right down into the centre of the base of support. So the key thing to understand with a line of gravity, and you'll be aware of this line of gravity from when we've looked at the force of weight, okay, so that gravitational pull, okay, so if we from the earth and pulling down, so when we look at this now, let's have a look at line of gravity. So if we're going to apply this factor, we've got to say that if the line of gravity runs through the centre of the base of support, it creates a balanced or stable position. For example, or we'll keep it with this on this one, a bridge in gymnastics. Now, what I should going to make really clear here, so that if we're trying to maximise stability, we want the line of gravity to run through the centre, as you can see here, of the base of support. Now the base of support here is hand, hand, foot, foot. So we want it in as close as we can to the centre. If that's the case, we are stable. Now sometimes sports performers do not want to be stable. Therefore, with regard to the line of gravity, they might want to minimise their stability. So they want to move their line of gravity outside the base of support, okay, or the centre of the base of support. So if the line of gravity travels outside the centre of the base of support, it creates an unbalanced or unstable position. Now you might be wondering what this application refers to. So let me give you an example. So if we look at, say, a side step in rugby, which is the equivalent to kind of pivoting or dodging in netball, I suppose, same with basketball. So if we look at a side step in rugby, let's have a look at how it works. So if you have a look here, the line of gravity has now gone. So if you look at the bridge here, the line of gravity in this case is going straight into the centre of the base of support. Okay, now what we have, okay, over here is the line of gravity on a side step that's going that way, okay, is coming outside the centre of the base of support. Now this lowers stability, which means the rugby player can change direction. Okay, can use agility and change direction quickly whilst under control, okay, and move off and try and kind of fool the defender or whatever they're trying to do. Okay, so that is our section on that. So it's really important that you do understand the two applications there of line of gravity. Sometimes we want it in the centre of the base of support, other times we want it outside the centre of the base of support to minimise stability. Okay, so hopefully you can see how that works. That's our second factor. Now, our third factor affecting stability is the size of the base of support. Now, we've just talked about it briefly there. So if we have a look at it from here then, the size of the base, and I'm sure you can work this out. Now, the size of the base of support then, if we're going to apply it to wanting to be stable, which the majority of the time in sport we are, okay, the bigger the base of support leads to an increased stability, okay, and I've put here increased stability of the centre of mass because it will make the centre of mass more stable. So in this case you have the base of support is big, okay, so you've got a kind of a rectangle there, not the best rectangle in the world, but you've got it goes to here, to here, to here, to there, all the way around. You can see that now. That is a wide base of support, or a bigger, greater base of support, which leads to increased stability of the centre of mass. Okay, so it makes that more stable. So the other thing that comes from having a bigger base of support, or can enhance the size of the base of support and therefore stability, is more points of contact. So in this case, you can see you've got 1, 2, 3, 4 points of contact. Therefore, those 4 points of contact will contribute to a greater or bigger base of support, which means that you're going to be more stable. Now, if you do this, and I'll give you an example of how you can compare it, a bridge in gymnastics, that's been our concrete example, okay, has a wide or big base of support. It also has 4 points of contact. You compare that to a handstand in gymnastics, and as you can see here, the size of the base of support is way smaller. On top of that, okay, so you look at it, that's just going there to there, whereas this one's going there, there, round and back, okay. 2 points of contact, smaller base of support, therefore this will have less stability. It'll make the centre of mass less stable. Okay, so you can see how that would work in a direct comparison there. Okay, so if there are factors affecting stability, complete, we've got those sorted. So we've looked at the height of centre of mass, the line of gravity, the size of the base of support. If you want to add to your notes, obviously the mass of the object will also dictate. The higher the mass of the object, the more stable it is. It's difficult to really see that in exam questions, but if you wanted to add that to your notes, you can. Okay, so if we move on from here then, the next thing we've got to have a look at is the changes in the position of centre of mass to maximise performance. So we've looked at factors that affect stability linked to the centre of mass. Okay, now what we have to look at, okay, some sporting examples or some sporting techniques really require a change in our position of centre of mass in order to maximise performance. And just to give you a couple of examples of exam questions you could get in this area, here they are. So high jumper uses the Fosbury flop technique. You hopefully will remember or recognise this from school when you did high jump. Okay, what we have to be able to do then is describe the changes in the position of centre of mass. In this case, it wants you to do a takeoff and during flight. Okay, so almost like a preparation and execution. Other type of question you could get would be this. So using a sporting example, explain how a performer can move their centre of mass outside the body to effectively perform a named skill. So what we're going to do, as you can see here, Fosbury flop will be a good place to start. Okay, so if we put it onto here, those who have no idea what this is about, hopefully you do. A Fosbury flop is a high jump technique, okay, whereby you arch your back over, so you backwards rotate, arch your back to get yourself over the high jump bar. Okay, so idea being, if you rotate backwards this way, arch your back, this will allow you to clear a higher jump than it would do if you didn't arch your back or you tried to jump over forwards. So that's what it is. What we're going to do then is have a look how the centre of mass position changes whilst doing this. We're going to split it into two. So now what we're going to look at now is we're going to split the Fosbury flop into preparation and execution and have a look at the changes of centre of mass for both of those key parts. So start point then. If we have a look at the preparation phase of the Fosbury flop for high jump, I just wanted you to have a think. So if we compare it to rest, if we have a look at the technique here, now there's not much in terms of technique you can talk about, but what you will notice, okay, I could have put a few other bits as they were running up. When they get to this point and they're just about to take off, okay, so the preparation to take off, when they do this, their arms rise. Now you should remember from earlier in the screencast, I said if your arms raise, this will lead to a change in the position of centre of mass. So in this case, our arms are raised, leading to our centre of mass rising. So it will go from what would have been a little bit lower down here, and it will move up to here when their arms raise. Okay. Now on top of that, in terms of our where our centre of mass is in relation to the body, during preparation, our centre of mass, because we haven't backward rotated yet, it's still inside the body. So our centre of mass remains inside the body, but the technique of raising our arms just when we're about to take off means that there is a raised centre of mass. So hopefully you can start to think what's going to happen now. So now we're going to move on to the actual execution or the in-flight part of a Fosbury flop. Okay, so what's the technique looking like here then? So you can see here on the picture, okay, so what we need to do now, so we can see the technique here is there is a backward rotation to arch our back, okay? So that's our first thing. So backwards rotation leading to an arched back. That's the technical thing that's happening. Now what we need to understand now is what happens to our centre of mass in relation to the body. So in this case, as you can see, the centre of mass now moves outside the body. So it's not there anymore, where it was when he was standing up. It now moves outside the body. And what's really interesting about this is the centre of mass travels under the bar, but the performance, how does it maximize performance? The body can arch higher over the bar, okay, but the center of mass goes under the bar, okay. So that is why the technique or the change in the position of center of mass maximizes performance, because whilst the center of mass goes under the bar, the body goes over in an arch position, which allows us to perform well. So you can see how you could use this as a really good example when talking about the change in the position of center of mass to maximize performance. Okay, so hopefully you can see that on there. You need to pick it up by saying technique, centre of mass in relation to the body, and then what does that mean for performance? Body arches high over the bar, which you could add this now, which leads to a higher jump. Okay, That's our final point. Okay, so hopefully if I just move on to the next slide so you can see where we're at, you should now be in a position within your notes to define centre of mass. You should feel confident looking at the factors affecting the position of centre of mass or change in position of centre of mass to maximise performance, which we just had a look at on the last couple of slides, and then the relationship between centre of mass and stability, or the factors that affect how stable we are. Okay, so that's what we're looking at. Hopefully you feel like that is accessible. I will have a work on that in lesson. Thanks very much.